Hello, everyone. I want us to look at some more examples on the mean, variance, and standard deviation of data. So here I will show you an example from the book of Clark and Cook. And if I consider the 4th edition, that will be example number 4.1. I think either I took it as an exercise or I think it's an example. So you can check through the book, but I extracted everything that is there, so you may not need to bother yourself. The example says that in a city, there are 6 professional clubs. Last season, they had 25, 30, 18, 27, 28, and 22 players respectively on their full-time paid staffs. Find the mean, variance, and standard deviation of the number of full-time paid staffs. Let us call the number of full-time paid staff R. It is easier to lay out the calculation in a form of table that is shown on the next slide. So R is like our variable, and this is a count. It stands for the number of full-time paid staff. So here we have, in the first column, we have club A, B, C, D, E, and F. So R is our variable, and the RI, that is an observation for a particular club. So here we have 25 professional players for club A, 30 for club B, 18 for club C, 27 for club D, 28 for club E, and finally 22 for club F. If we add all those, then there are 150 in total, the number of professional staffs. We can have the mean, and the mean is just, we have 6 clubs, so we divide it into the total number of 150, and we get 25 professional staff per club. We can get deviations from the mean. So 25 minus 25, you have 0, 30 minus 25, you have a 5, up to 22 minus 25, you have minus 3. We can square those deviations, and you have 0, 25, 49, 499. We can get an average of those square deviations. Now, when we do that, you would recall that if we square deviation, we square the deviations and add all of them, so we have a summation of all these. If we divide by the total number of observations or the total number of clubs, what we get basically is the variance. Here, these are raw sum of squares. We can also use this if we want for getting the variance. You remember we can sum this raw sum of squares, subtract this total. So you have the total square over n, and whatever you get from there, you should also divide by n, which is a 6. So we saw this one, I think, in some proofs. Now, if you do that also, you should get the same 16 as the variance. And if we divide, not divide, but we take the square root of the variance, which is 16, it will give us the standard deviation of 4. So our mean can vary with 4 professional players. So that's the variability. That's in terms of standard deviation. So it's easier if you lay out your data in this format to track your calculations, but you can do it in any manner you want. So that was just the variance of data that is ungrouped. At times, as we have seen before, you have grouped data from frequency distributions. For example, let the table of values of discrete variable be R1, R2 up to Rk. So those are variable values. And frequencies for R1, you have F1, and F2 for R2, F3 for R3, Fk for Rk. The total, if you sum all the frequencies, this gives you the total number of observations. And the total of all observations, so if we sum each of the set, all the observations, we sum them, then we get this. So just multiplying the frequencies, a particular frequency corresponding to a distinct value, and sum them, you can get the total of all the observations. So the variance and standard deviation of grouped data, grouped frequency data, will be defined as in the following sections. For example, the variance of a set of n observations of a discrete variable grouped so this should be grouped so that the values Ri, I from 1, 2 to k, occurs with frequency Fi is as follows. So if you look at this we know these are just deviations from the mean, and they have been squared. So these are squared deviations from the mean. Each squared deviation is multiplied by the frequency, which we observed for a distinct value for that discrete variable. And when we sum the product of this, then we get the total and divide it by n. That will give us the variance. Alternatively, we can use the other formula. You remember, these are raw sums of squares, and this is the frequency. Then this, we already know Ri, summation of xi, bracket square. Now we multiply by frequency. Before we do the square, we have to do this. If we divide by n, and the entire quantity divided by n. The expression in the large brackets may be stated in words as the sum of squares of all the observations minus the total squared and divided by n. An example on grouped data. So here we have a number of people absent. For example, Ri, which you have 0, 1, 6, 2, 3, 4, 5, 6 or more. A number of days absent. For those absent, never absent, we have 44 people. Absent just one day absent, we have 19. Okay, number of people, when only one person, when no people, nobody's absent, we have 44 days. When only one is absent, we have 19 days. Only 2 absent, 10 days, 3 absent, 8 days, 4 absent, 7 days, and so forth. And this is the product of the frequency and the respective value, the product of the frequency and the respective values squared. So if you sum frequencies here, you have 91. These are 91 days. And then here, you can sum the products. You have 105. You can sum the product between the squared values and frequencies. You have 318. So here you have options of using any kind of formula that you may wish to use. You can use the formula with deviations, square deviations. You can use the formula with row sums of squares. So here, if we choose to use the formula with square deviations, then we may not need this mean. However, to get the mean of group data, then it's just summation of the product between the frequencies and the corresponding distinct value divided by n. So here is 106 divided by 91, which is 1.165 days. That days, or that shouldn't be days, that should be number of people absent on average for a particular day. And then the variance. So the variance here, now we use the formula which considers the raw sum of squares. So we don't necessarily need the mean. And we use the totals that we have had. We knew we got FIRI. The summation here was 106. So what we do is just square there. But we also got this summation. It was 318. So 106 squared divided by 91, and then subtract this from 318. So what you get inside the bracket also divide by 91. So here you have 194.53 divided by 91, and this is our variance. So 2.13377 square. So to get the standard deviation, you have to take the square root of the variance, and we have 1.46 as our answer. Now, again, we can also work with grouped observations from a continuous variable. And we know some of the techniques, how we do it. So the variance of a set of n observations of a continuous variable in which fi observations fall in the interval whose center is xi for I from 1 to up to k is as follows. Now, you take note what just changes is the x. These are the x's. So we have x bar here, we have xi. In the other discrete case, then we should have had ri and r bar. So nothing really that is changing, except that before you do the calculations, you need to know your intervals. You need to calculate the class centers. And then when you calculate class centers, basically the formulas will work in a similar manner to those of discrete values. Okay, let me stop here for now before we proceed on other lessons. But for now, I will ask you to try to work on the exercises that are in the book of Clark and Cook. They are quite useful. So please, there are a number of exercises that you can do. It's very important that you review those exercises. Thank you so much.